Hey guys, what we're going to do today is look at a subnetting example problem. Basically, this is the sort of problem that you would get if you were asked to do problems on a certification test. And it's something that you might possibly see in the real world. What you're going to do basically is take a single network and divide it up into a number of pieces, and that way the customer can divide his business up and segregate his network traffic and make his network run a little better. So let's go ahead and look at the desktop, shall we? Okay, so here we are at the desktop. Now, essentially what we're going to do is we're going to take an address, or a network, and we're going to divide it up into pieces. So the problem, as stated, would be like this. Your supervisor comes up to you and he says, we have a client. He wants his network divided up into 3 subnets. He wants one for marketing, he wants one for production, and he wants one for the public. So our job is to divide his network up into 3 pieces. And to do that and to set it up in a router, we're going to need to know the network ID, the broadcast ID, subnet mask, the number of hosts for each network, and the range that those hosts are going to fall into. So that's the information that we need to find out. The information that we are given is the network ID and the subnet mask of the original network. So in this case, the original network ID is going to be 192.168.4.0/24. That gives us the network ID. That's the lowest possible IP address in the network, and the subnet mask in CIDR notation. CIDR notation is a /24, 25, 26. So basically, given that information, we need to make 3 subnets, and we need to have the maximum number of hosts that are available in each one of those 3. So to do that, we're going to use this table here. This is a really handy little thing. You can memorize it pretty simply. Just start off 1 to 256. That's the number of subnets you're dividing into. Hosts is how many IP addresses are available in each subnet if you divide it, starting at 256 divided by 2 divided by 2, and so on down to 1. And the subnet mask start at /24. That's with 1 network and no divisions, all the way down to /32. That would be 256 subnets, which wouldn't be very practical because you would have basically 1 usable IP address in each one of those subnets, and that would not give you a broadcast ID and a network ID, so you couldn't really do that. In fact, you really couldn't practically divide a network into 128 pieces because you would only have 2 available IP addresses. That would give you your broadcast ID and your network ID, but you wouldn't have any other usable addresses. So the smallest you could practically divide a network into would be 64 pieces. That would give you a network ID, a broadcast ID, and 2 usable IP addresses, which would be kind of pointless because that would give you a router address, and then that would give you 1 computer to hook to the router. So that wouldn't be very practical. Mostly what you're going to see is dividing it into 2 or 3 or 4 or 5 or 6 pieces or whatever. You won't see that many divisions in a single network, or at least I can't imagine a time that you would. So anyway, let's go ahead and get started. Remember, we have our given information, the network ID, which is the lowest possible IP address in a subnet, in this case 192.168.4.0. The subnet here is subnet mask rather /24. If we look at our table, that makes sense because with 1 network, the subnet mask is going to be /24. Now, the problem we have is that we don't see a 3 in this group. There's a 1, a 2, a 4, an 8, a 16, so on, but there's no 3. So what we're going to have to do to answer this question is, instead of dividing into 3, we're going to divide it into 4. If we leave it alone, that doesn't help because he only has 1 network to work with. If we divide it into 2, that doesn't help because he's going to be missing one of the 3. It was marketing, production, and public. So one of those guys won't get a network. And so we can divide it into 4, and that will give us the other requirement, the maximum number of hosts for each subnet. If we divide it any bigger, we're going to reduce the number of hosts we have. So the maximum number of hosts we can have in each subnet and still get 3 subnets is 64, and that's dividing the network into 4 pieces. So knowing that answers most of our questions for us. So let's go ahead and draw a circle around 4, and that will tell us a great many things right there. If we're going to divide our network into 4 pieces, then first of all, that tells us what our new subnet mask is going to be. Subnet mask for each of those networks is going to be /26. With one subnet up here, one subnet or one network, it would be /24. We're dividing it into 4 pieces. That moves us to /26. So that gives us what our new subnet mask is going to be. And in fact, we can go ahead and put that in for all of them. Let's just go ahead and fill out that information now. All right, so there's a big portion of our work is done for us. Alrighty. So now we've got our subnet mask in. The new mask is going to be 26. That tells us we're dividing it up into 4 pieces. Now, where to start? The network ID for our new first subnet is going to be the network ID of our original subnet. This is going to be the lowest possible IP address available to the whole group. That's going to make it the lowest possible IP address available to the first original subnet. So we're going to go ahead and make that our new network ID. The only difference is it's going to be /26 instead of /24. That is the difference. So our new network ID for the lowest possible is address in this group is going to be 192.168.4.0/26. We've changed it up here from /24. This is the place that we're going to start. All right, as far as our number of hosts, well, it tells us in our table. If we divide 256 by 4, that's going to give us 64 hosts. So originally, the number of hosts is going to be 64. However, those are not usable hosts. The network ID here and the broadcast ID are reserved. Those IP addresses can't be used. And so instead of having a total of 64 hosts per section, we're going to have a total of 62 because we've got a network and a broadcast ID for each of the sections. So we're going to have to take those out. So that will give us a total in each subnet of 62 hosts. So that answers another big piece of our puzzle there, is how many of these we can have. So now we've divided up our network evenly into 4 pieces. Each one of those pieces has 64 total addresses. However, only 62 of them are usable. So each section only has 62 usable addresses plus a network ID and plus a broadcast ID. Well, it should be simple then. If this is the lowest and this is the highest, and we're going to have 62 here, we've got a 0, and then 1 through 62 is going to be the usable addresses. So that gives us our range. And then our broadcast IP is going to be 63 because, like I say, we're starting counting at 0. The total should be 64, but because we start counting at 0, that backs it down to 63. 0, 1, 2, 3, 4, 5, 6, 7 to 62, 63. So we can go ahead and put our broadcast address in there. That's going to be a /26. All right. Now, we figured out the range. From this, we know that it can't be lower than that and it can't be greater than that. So it's going to have to be between there. The next one after .4.0 is going to be .4.1. And then the one right before .63 is going to be .62. So our addresses here in the range are going to be 192.168.4.1, 192.168.4.62. I'm not going to put the subnet mask on there, but just know that there should be a /60 or /26 at the end of this. But it just takes up too much room, so I'm not going to put it in there. All right, so there's our first line we're taking care of. Now it's easy because we know that this marks the end of our first subnet. So the next one, the one after this, is going to mark the beginning of our next subnet. The one that comes after 63 is 64. So we're going to come down here and go 192.168.4.64, and that'll be a /26. Okay. So we've got 64 and then 65 through 126. What would 62 plus that be? So that would be 126. So our next one after the most last useful one would be 127. So our broadcast ID is going to be 192.168.1.127/26. Okay, there's that. And so the ones in the middle are going to be 65 to 126. So let's go ahead and put them in there. .126. Okay. So that gives us our next section. There we go. Okay. So we know that if we end here at 127, the start of our next section is going to be 128. 192.168.4.128/26. And then we got 129 through 191, I believe it would be. And that will give us here at 192. Okay, so there's that. That's our broadcast. And so the range is going to be 129 to 191. Okay, and then finally, last one, of course, is going to start after 192, so that's going to be 193. /26. And that's going to go all the way to 255. That will be the broadcast IP there. And the range is going to be 194 to 254. 28. Get a calculator. We're going to go with that. All right. So we're going to go 192.168.4.194. 192.168.4.254. And that answers all the questions that we needed answered. So let's go back and review. The original question was we needed 3 subnets with as many possible hosts as we could possibly get in there. We needed the network ID, the broadcast ID, the new subnet mask, number of hosts and what range those hosts would fall into for each of the new 3 subnets. Well, we couldn't divide it into 3, but we could divide it into 4, and that would still give us the maximum number of hosts that we could have. So we did that, and when we divided it into 4, that gave us our new subnet mask of /26. That also told us how many total hosts we have. Of the 64 total hosts, only 62 were usable, because this network mask and this this network ID and broadcast ID are not usable. Those are reserved addresses. So we only had two addresses we couldn't use of the 64, so that leaves us 62 addresses available for use in each of the subnets. And then we started off at the original network ID for the original network, .4.0. That's 1. Then 62 usables. That would bring us up to 62, from 0 to 62. And then we added the next one for the broadcast ID. That's 63. So we know that that marks the end of the first subnet. The second subnet, of course, has to start at 64. And then so we're at .4.64. And then usables would be 65 through 126. And the broadcast ID would be 127. That marks the end of the second, the start of the third. We got 128, and then 64 of those later is 191. Or pardon me, 62 later is 191. And then that brings us to 192 as our broadcast ID for that third. And then the start of the fourth is 193. And then 62 would bring us to 254. And then the final address, the final broadcast ID would be 255. So that is how you divide up a network into multiple pieces. What we would do then is we would not use the last subnet. We would just set that off to the side and not use it. We would set the routers to give 62 addresses, and the first one would start 0 to 63. Then 64 to 127, 28 to 192. We wouldn't worry about 193 till 255 until maybe at some point in time the customer wanted to add another subnet. We'd have it available. But these would be the way to divide a network up into 3 pieces and still provide the maximum number of hosts in each section. So that is how you would answer that problem on a test. All right, guys, I hope that was helpful. We'll probably work through some of these in class once we get up to around Module 8. These are not hard, but they're just involved. And so that's the main thing that we want to look at is we want to get good at these. We want to know what the different numbers mean, and we want to know why the numbers are there. So I'll leave you with this one. I would go back through this, watch it a couple times, kind of maybe practice it, change the original value, change the network, change the requirements, divide it up into 5 pieces or 7 pieces or 9 pieces or whatever, and we'll go from there. And if you have any questions, as always, the Canvas inbox or send me an email, and I will do my best to help you. Have a good day.